Welcome to this introduction to Progsbase. Progsbase is a new theory and technology for software development. It attacks two main problem areas, the problem of software rot and the problem of software reuse. The benefits of using Progsbase to develop software is that it reduces passive software rot, which means that code lasts longer. A second benefit is that it increases the possibilities of reuse. And a third benefit related to the first two is that there are less bugs in the code. To see how Progsbase achieves this, let's do a little bit of an analysis of what software is. Now, a piece of software usually consists of a list of text files with source code in them. This is what the left side of this window shows. Here we have a collection of text files, which includes the source code of some piece of software. This is what most people think about and work with when they do software engineering. Of course, these text files would be nothing without the dependencies that they depend on in order to work. And some dependencies are listed on the right side of the window. Now, the first and most obvious dependency of software is the hardware that it runs on. Now, three major platforms of hardware is Intel with their x86 platform. We have ARM running on most mobile phones, and IBM also delivers hardware for software. Intel for the most part delivers hardware for desktop applications. Now, this forms the basis of where software runs. Now, on top of the hardware, we usually, or always, I can say, need an OS, an operating system. Now, the three largest operating systems are Windows, Linux, and Mac. An operating system usually also comes bundled with a lot of libraries, and some of these libraries are used via interrupt mechanisms. A third category of dependencies are libraries. Now, these are libraries you download from the internet or purchase from a library vendor. Now, these three categories of dependencies are still not enough to run the software. We also need a programming language, and the three major programming languages are Java, C, and Python. And of course, we need to use a specific version of one of these languages. So, for example, Java 11, C 11, or Python 3. A sixth category of dependencies are peripherals and the contents of them. For example, most machines have a disk, and the disk has some contents. Need network card and what is available on the network, be it the local network or internet. And a screen, for example, be it the size, or you can also have multiple screens. Notice that the software is really dependent on all of these. Let's look at the first one. If you have a program which depends on Intel-specific instructions, it will not work on a machine using ARM. So you're really dependent on a particular hardware vendor. Now, if you look at the operating systems, you're also dependent, most likely, on a particular operating system vendor. For example, you might be utilizing the Windows API. In that case, it will be difficult to run it on Linux or on Mac. What about libraries? If your code depends on a certain set of libraries, then it simply will not work without them. And the libraries are not easily changed by other libraries. What about programming language? Now, if your code is written in Java, it obviously does not run using Python. The same thing goes with versions of a programming language. If your code is Python 2, then it doesn't work on Python 3 because of breaking changes. Now, regarding peripherals and their contents, if your source code depends on a particular file on the disk, then your code will not work. If your code depends on some internal or external web service, then the code will not work. And if your code requires a screen of a certain size or multiple screens, then your code will not work. So these dependencies are really important, and you depend on particular versions of each of these dependencies. So that is a bit of a background to where Progsbase enters the picture. One really important idea is modularization of software, and most agree that this is a good idea. Your code should be split up into separate modules that focus on some particular area. This is to avoid monoliths, as it is called. So this is an almost universally accepted idea in software development. Now, the first idea that underlies Progsbase is a criterion for how to modularize software. And this criterion is called Computation-Infrastructure separation. Now, on the left side of the screen, we have the computational modules. The computational modules consists of computations and data manipulation. Now, on the other side of the screen, we have the infrastructure modules. And infrastructure modules deals with disks, networks, clocks, other CPUs, screens, graphics, graphic cards, web services, consoles, mouse, keyboard, timers, serial ports, and other kind of infrastructure. If we modularize our software so that some modules are computational modules and some modules are infrastructure modules, we can analyze further the properties of these kinds of modules. So, the computational modules are stable. They are usually more than 80% of the code of a software product, but it can be as high as 98 to 100% of a module. And computational modules are very often mature. Now, if you look at the infrastructure modules, they are usually unstable. They are usually less than 20% of the code and can be as low as 2 to 0%. And they are usually immature in the technology that I've used. Let's look at an example. So there's a system called Axis, which is a system for designing airport antenna systems. Now, this system consisted of 98% computational code. These are computations dealing with how the antenna are to be designed in relation to how the airport is laid out. Now, only 2% of the code was infrastructure code, dealing with loading files from disks and showing the graphics on screen. Now, when I first looked at this project, it was non-modularized, it was mixed. So the whole code base appeared unstable. Now, the code was salvaged in the following way. First, it was modularized into computational modules and infrastructure modules. So we isolated the unstable infrastructure modules, and we could then rewrite those parts, and the computational modules were stable so that the whole code became stable. There are many other examples of areas where software is highly computational. For example, banking, finance, pensions, financial instruments, interests, stocks, bonds, risk, insurance, trade, accounting, stocks and pricing, designing and administrating these things, for example, airports, logistics, energy, communications, water systems, factories, train systems, antenna systems, satellites, roads, buildings, and cars. Of course, gambling and multimedia, for example, audio, video, and coding. Let's now focus on computational modules. As I said earlier, this is the highest percentage of code of a software system. This is the most stable part of a software system, and it is the most mature, technologically wise. Now, what are some of the computational code constructs that we encounter? Now, for example, in C, C++, Python, and Java, we have floating point arithmetic and integer arithmetic. Some characteristic features of C is pointer arithmetic, unions, and inline assembly. Some characteristic C++ features are templates, object orientation, multiple inheritance. Some characteristic features of Python are dynamic typing, functional programming, object orientation again, and garbage collection. Java also has garbage collection. It also has generics, reflection, and also object orientation. Now, the second main idea of Progsbase is to separate out the established constructs. Now, if we look at the left side of the window, the established constructs in code tend not to change over time. There's a high agreement on how they should be, and most languages have them. The non-established features of a programming language tend to change over time. There's a low agreement on how they should be made, and most languages have their unique features or versions of a feature. The third idea of Progsbase is the following. The use of non-established constructs causes passive software rot and inhibits reuse. So in other words, the use of established constructs makes code last and promotes reuse. It is interesting to note that a few constructs is needed to make most computations. The established constructs are a comfortable set of constructs. Most programmers already know them, and they are easy to learn and use. Let's now look at Progsbase. Now, the Progsbase theory is a selection of established features. The following features have been selected for inclusion in Progsbase: floating point arithmetic, ifs and loops, functions, data structures, arrays, floats, Boolean characters, strings, and expressions on these, and the major mathematical functions. Now, what technology comes with Progsbase? We have built an analyzer, which verifies code for the use of only established features. It takes Java as an input language for now. There's a converter, which converts code to other languages. 13 different programming languages are supported right now. There's a dependency resolver, which resolves dependency in any of the 13 languages. And there's an uploader, which uploads code to the central Progsbase repository. So the way you use this technology to work with Progsbase is that first you create software using the Progsbase theory. You write using only the established constructs I discussed earlier. Then you run your code through the analyzer, which verifies that the code only uses these established features. Then you can use a dependency resolver to resolve the dependencies of your code in the language that you use. And finally, you upload your code to the Progsbase repository for others to reuse it. Progsbase has already been used for a number of libraries and projects. The open source libraries that also form the standard library of Progsbase now includes more than 14,000 lines of code as of recording this video. Now, the library consists of libraries for matrices, vectors, hashing, encoding, compression, 2D graphics, mathematical transformations, arbitrary precision arithmetic, statistics, graph algorithms, and more. A major example is the JSON library, a 100% standards compliant implementation of JSON, which is available in 13 different languages. Progsbase has been used for 2 commercial projects. One is, as of recording this video, one is a barcode generator, which has been used for barcodes of more than hundreds of thousands of printed products. The other major use case or project is the Axis software showed earlier. Now, experience with the project so far is that the Progsbase language is easy to learn 100%. Now, this is something quite unusual for a programming language. I would argue that learning a modern programming language such as C++ or Java, even 90%, probably would take you more than 10 years. So it's a very special feeling to code in a language where you understand the language 100%. Now, the code you write is easy to understand and analyze. Now, the reason is that you understand the language 100%. And when you understand the language 90% or less, it's not easy to analyze the code. Development is faster. The reason is that you focus on solving the problem and not on understanding the language. A lot of development in modern programming languages consists of looking up details of the language in documentation or looking up answers on Stack Overflow. Now, all of this makes for code with less bugs. There's less fancy trickery and more focus on solving the problem. And the last point on the slide is important. If you use non-established constructs, you will incur maintenance costs later. To summarize what Progsbase is, the first idea is the separation of computations and infrastructure. You can use Progsbase to make the computational modules, and you use your favorite language for the infrastructure modules. Now, in order to build the computational modules, we can separate out established constructs of programming languages. And this is where Progsbase tools and theory comes in. And the idea number 3 is that if you choose to use non-established constructs of a programming language, you have to take into account that this can cause passive software rot and inhibits the reuse of software. Now, if you want to learn more about Progsbase, you can look at the homepage, at the open source library of Progsbase code, and you can look at the documentation with the detailed description of the included constructs in Progsbase. Thank you.